the element. Chain is nothing but a linked list. 3 is mapped here, so we will add a node to a chain and insert 3. 13 is also mapped here, so we'll add a new node and there we will insert 13. So when there is a collision, we will insert a key element at the same index in a chain, right? So all these elements are inserted into their indices inside a chain. Now, when I want to search for any key element, let us say 13, then I should use hash function. H of 13 is 13 mod size, that is 3. 13 mod 10 gives me 3. So go to index 3 and search for that element, key element in a chain at that particular index. So there may be more than one element, so we have to search that entire chain, entire linked list. So that's how. Now the time complexity of hashing will not be order of 1, it will be more than 1, but it will be better than log n, it will be faster than log n. Now let us look at other methods. Now let us look at next method, linear probing. In this, hash function is h of x equals x mod size, same hash function I am taking. 8 is mapped at 8. 3 is mapped at 3. 13 is also mapped at same location, but there is a collision, so we store it at next location 13. So in this method, we simply find the next free space and store the element in next free space. So what is this approach? We should give the reasoning in mathematically. So here, there's the explanation. Our actual hash function is x mod size. We define a new hash function h dash of x, that is h of x plus f of I mod size, and f of I is equals to I, where I takes values 0 or 1 or 2 or so on. Now, when we use 13 and we have to insert 13, then we say h of 13 plus f of 0 mod 10. This gives us 3, but there is a collision. So next we use the same hash function for a different value of I and find f of 1 mod 10. So we got the answer as 4. So that's how the value is stored at location 4, index 4. So we use this h dash x as a hash function and we store the element. If there is a collision, then we take the next value of I. Even if there is a collision again, then we take the next value of I and so on. Now let us insert the rest of the elements. 6 is stored at 6. And 4, there is a collision, already some element is there, so we store it at next place, and 10 is stored here. Now when I have to search for any key element, let us say I am searching for 4, then I should use this hash function h of x equal to x mod size, go to that place 4, but the element is not present there. Then I should look at the next location, that is 4. Yes, it is found here, so it is found at index 5. So it means by using the hash function, I should go to the index and start looking for the element in the consecutive locations. If I have a key element, if I have to search for key element 24, then 24 mod 10 gives me index 4. When I go to index 4, 24 is not present. Then I should move to next location. It's not present. Next location, not present. Next location is empty. So I should stop and say that 24 is not found. So I can say that for searching any key element, we should use hash function, go to that particular index and start searching for the element until the element is found or empty space is reached. This is the method for searching. And again, the time complexity will not be order of 1, it will be more than 1, but it will be better than log n. Now the problem in linear probing is it causes clustering of element. A bunch of elements will be at one single place at consecutive location. They will be allocated continuously. So this may cause a lot of time for searching any element. So to avoid the clustering of elements, we introduce quadratic probing. Quadratic probing. So this is same as linear probing, where if I take the hash function, then for this also we define a new function h dash of x. It is h of x plus f of I mod size. But f of I is I square. I takes the value 0, 1, 2 and so on. So it's not f of I is not equal to I, f of I is equals to I square. So the difference between linear probing is in linear probing f of I is equals to I we take here. But in quadratic probing f of I is equals to I square we take. That is the difference. Now when we try to map the key element, 8 is stored here, 3 same place, 13 for I as 0 there is a collision. So for I as 1 it will be stored at next location. Now next is 23. So let us find out for 23. H of 23 plus f of 0 mod 10. This gives 3. There is a collision. At location 3 there is a collision. Then h of 23 plus f of 1 mod 10. So this is 3 plus 1 mod 10 is 4. At 4 also there is a collision. Then we find 23 h of 23 plus f of 2 mod 10. So this is 3 plus f of 2 is 4 mod 10 is 7. So this 23 there is a collision here, so it is stored at index 7. Now you can see that the element is kept few locations away. It's not very close to the elements which are getting collision with 23. So there is a gap in between the elements. So this will avoid clustering of elements and improves the searching time. Hope you have understood hashing. Thank you for watching this video.